This lesson we're going to talk about variables. So let's create a new class. We're going to call it variables. Call it variables. Then let us add our main class. So public static void main. We have that, and say string args. We have square brackets, then we have that. So let me zoom. Yep, hope that is visible now. Okay, so let's talk about variables. So what is a variable? A variable is basically a basic storage, or you can say a memory location in a Java program. A basic memory location in a Java program. And normally a variable consists of the identifier. So it has the identifier. It also has a type, and also has an optional initializer. By optional means it can be there or not. And also have an optional initializer. So all variables, they have scopes that are actually defining their visibility. I'll talk about variable scopes later. So the first thing that I want us to talk about is declaring variables. How do you declare variables? We have already done a variable declaration. Let me just talk about it. Declaring variables. Now, to declare a variable, you need to indicate the type and the identifier. The type is which data type is that particular variable that you're creating. Number two, the identifier is the name that you are giving to that identifier. For example, int salary. So when I say int salary, I'm trying to say create a memory location, call it salary, and that memory location should be able to store values that are of type integer, or it should be the size of an integer. So that is what I've done there. I have declared the variable salary that can store integer values. So the type is actually the atomic type. It can be a name of a class or even an interface. Then the identifier is basically the name of the variable. So if you want to declare more variables of a specified type, you can use commas. I've shown this previously. So you can still say salary. Maybe we're talking about salary, then we're talking about deductions. Deductions. Okay, tax. Let's say tax. Okay, tax. And then let's have something like what? Expenses. Maybe expenses. We have declared 3 variables. So we are telling the compiler to create a memory location called salary, that is of type integer, that stores values of type integer. You are telling it to create another memory location, give them the identifier or the name tax, and that is of the size of an integer, and create another one with the name expenses and give it make it the size of an integer. So we said a variable consists of an identifier. The identifier here is salary, tax, and expenses. A type, the type is int, and an optional initializer. So right now, when we are declaring variables, we don't have initializers. So we can go to variable initialization. Variable initialization. So when we are assigning a variable, we actually we are specifying a value for that variable. Okay, we are specifying a value for that variable. For example, now we can say salary is equal to 10,000. Let's assume you are a Kenyan. Salary is equal to 10,000. So one very important thing that you need to know is that the is that the initialization must actually be resulting to a value that is of the same type as the specified variable. So we said it is the int here, the salary is of type int. So as we are initializing int, whatever we give here should be of type int. If we make a mistake and say 10,000.90, boom. Now you see there's an error coming here, this one. When you hover on this error, you see it's written type mismatch, cannot convert from double to integer. Why? We said Java is a strong type, so it cannot do implicit type conversion. If we want to convert types, I'll cover that much later. We have to do it explicitly. I'll cover that in another lesson. So that's something to note, that whenever you are actually initializing, make sure that expression is going to yield to a result that is of the same type as the declared variable. It's very important for you to actually know that. So salary is equal to 1000. We can just initialize all of these for the sake of illustration. You can say int, maybe not int, you can say tax. This guy is paying tax 2000. This is Kenya. Okay, this is Kenya. All right. You are paying 20%. Okay. Is it even 20%? Yeah, it's 20%. So tax. Then let's talk about let's calculate the expenses, assuming that this guy only pays okay, let's have some expenses. Maybe the guy pays rent, let's say it's 2500. Yeah, the guy pays rent, it's 2500. So can we print what this guy is left is left with? Let's call it net income. Net income. Of course we need to declare it with int here, because net income. So say, what is this? Come on, let's say int, and then we say net income, and then we initialize it to the salary. We subtract the tax, we subtract the expenses. Let's see, this guy is left with how much. Let's print the net income. So system dot out dot print ln. Let's print the net income. Here we are printing net income. We are printing net income. So when we print net income, let's see how much is this guy left with. How much is this guy left with? Life is very difficult here. Yeah, so let's check the output. So the guy is left with 5500. Okay. So that is basically declaration and variable initialization. So again, there is another concept we need to discuss. It's called dynamic initialization. For this, I need to create. Let me just create another class. So I'm coming to here, Java lessons. Right click. I say new. I want to create a new class. So new class, and I'm going to name it dynamic initialization. Dynamic initialization. Hit enter, and now here we are. So let's put our main class. So say public static void main, public static void main, and we say string args square brackets, and then we have curly braces. So we are talking about dynamic initialization. Dynamic initialization. So dynamic initialization is an initialization that is done using any expression that is valid during the time the variable is declared. For example, if we create we can write a program that computes the length of hypotenuse. For instance, let's say we have our let's have double we say hypotenuse is obtained by, okay, let's initialize a to 4.6. Let's initialize b to 8.4. These are just random values, guys, and I want us to dynamically initialize c. So let me put this and say c is dynamically initialized. C is dynamically initialized. So we say c. How do we get c? In other words, how do you get the hypotenuse? So you have to say int c here. Is it int? No, double again, double c. So how do we get the hypotenuse? We get the hypotenuse by, I'm just going to use our math function. So math dot the square root sqrt, math dot the square root, and it's the square root of a, the square root of a. We need to multiply a with a plus b, so we can use parenthesis, a plus b, then we multiply this by b. So we say it is a squared plus b squared is equal to c squared. So to get c is the square root of a squared plus what? Plus b squared. Yep, that's it. So let's print c. System dot out dot print ln. We are printing c. So let's run our program and see the output. It is 22.412. So that is actually the hypotenuse. So the concept here is this one, c. C is dynamically initialized, meaning an expression has to be executed when the value is obtained. Now that value is stored in double. Don't worry about math.square, the square root. We'll talk about that much later. The concept that I want you to take home there is the dynamic initialization. So if you look at a and b, they are initialized by constants, while c is actually initialized dynamically to the height using the hypotenuse theory. You have used the hypotenuse theory. Then we have the sqrt, which is a built-in Java method. It's actually a member of the math class. We'll talk about that when we come to classes. So the next thing that we need to talk about is the scope and life of variables. Scope and life of variables is actually the next thing that I want us to talk about. So here we are going to create another class again. Don't get tired of creating classes. We get this, and we are here to do this. So let's create a new class. I just call it variable scope. Variable scope. Call it variable scope. Let's add our main class. So public static void main, say string args. So we have that, square brackets, and we open with that. Okay. We are talking about the scope and lifetime of variables. So it's important to understand that variables in Java can be declared at the start of the main method, just exactly as I have been saying. So int main, int a, I have declared a variable at the start of the main method. You have public static void main. So Java also allows variables to be declared within a block. You can have a block of code. A block of code is normally shown using it normally begins with an open curly brace and ends with an open curly brace. And for example, if I say something like if a, then I say I put that. Then inside here I say int b, and I assign 100. Just show you something. Then here I say let me just say int a and say int a is 23. All right, so we can actually create another variable here, int c, give it 50. Okay, so if a is, let's say if a is less than c, for instance, that is a condition. If a is less than c, we are declaring b inside here, inside this curly brace. Remember, I have said the curly braces shows scope, so you can say beginning of a block, and of course this one is the end of the block, so we said we show blocks using curly braces. We show blocks using curly braces. So it is an if block, it's beginning here and it's ending here. So we said or I say that these blocks normally determine a scope. They determine what variables are visible to what code or to what parts of the program. They also determine if they determine also the lifetime of the objects that we have inside there. So most programming languages have two categories of scope. We have global, they have global and local. But in Java, we have two major scopes that are defined. One is defined by a class, and those that are defined by a method. So I'll talk about that. So until when we are talking about classes, now we're just going to focus on the scope within a method. Okay, so that we can have a generalized idea of a scope. So the general rule of variable is that variables that are declared within a scope are not accessed to any code that is actually outside the scope. Now, for example, we have the variable b here. Let me just show you a simple example. Here say b is equal to 100. Okay, let me print let me say b is equal to a plus 50. B is equal to a plus c. Yeah, notice that a and c are declared outside this block here. They're declared outside this block, so they are all in a public scope in our main class. But b is declared inside this block here, so it is in the scope of that block of code. So the fact that we can say int b is equal to a plus c and we don't see any error here, what we see is the value of the local variable is not used. That is not an error, so we don't see any errors. It means now it is possible for b to access a and c because a and c are in the public scope. But the question is it possible for b to be accessed outside that block? That is the question. Is it possible for us to access b outside the block? So let's come here outside. Let's get outside of this block. Let me just show you some magic. Outside of this block, let's say to c. No, it's not c, because c is public. Let's say int d is equal to b. That's what I wanted to say. Yeah, because if you say c, there should not be an error, because c is in the public scope, so there will be an error. But if you say d is equal to b, we see an error here. Let's check the error. What does it say? B cannot be resolved to a variable. Why? Because b is in this block, and that block defines a scope. It means that b cannot be accessed by any code that is outside that block, because we declared it inside that block. So it is inside the if block. It has that scope, so you cannot access it from this level. That is why when we say int d is equal to b, it is giving us an error. The same thing if you want to print, let's say you want to print b and we want to print it from outside. System or system.out print ln, and we want to print b. So again, same error. So let's come here, check what error is there. B cannot be resolved to a variable. Yes, because we are printing it and it's inside here. But you see, we can, if we take this statement inside this block, we paste it inside this block, just want you to see something. Paste it here. You see, there's no error. There's no error anywhere, and we can run this code, and it will definitely run. The code will definitely run because we are accessing B from its scope, and that is very much possible. But if you are trying to access B outside its scope, then so it shows us 73. Let's come here. Is B 73? A is 23 and C is 50, so we are adding the 2, so B is actually 73. But notice that we can access A and C inside this scope. Why? Because A and C are declared in the public scope. So remember, the general rule is variables declared within a scope are not accessible to code outside the scope. So when you declare variables within a scope, you are localizing those variables, and you are actually protecting the variables from access and even modification. So when we have nested nested code scope, when we have nested code, scope is also nested. So variables that are actually declared in the outer scope are accessible to the code declared in the inner scope, but variables declared in the inner scope are not actually accessible to the code in the outer scope. This is what I'm trying to say. You see, the if block here, the if block is actually inside the main. It is actually inside the main. So the if block itself, it has a public scope. This code has a public scope. So the if block plus any code, any variable declared inside the if block is accessible to any code that is in the public scope. Now, the code inside, the variable inside the if block is declared inside that block, so it has a local scope. We have actually localized it. It has a local scope, so it cannot be accessed by any code that is actually outside that block. That is why when we're trying to access B outside this block, we are getting an error. Okay, so I hope that is clear. So we can look at another example so that we understand better what I'm saying. We can just have another example program here. So we can just say int x. Now x, the moment we say int x, then it means that x is visible to all the code within the main. So let's put that visible to all the code within the main, because x is declared at the public scope, so it is visible to all the code in the main. Let's assign 30 to x. X is equal to 30. Let's have an if block and say if, let's say if, then we supply the condition. In this case, if x is equal to 30, if x is the same as 30. I'll talk about this operator. You might be wondering why I'm saying equal instead of equal. I'll talk about operators later. So let's have this curly brace. This is the start of the block, and of course this is the end of the block. This is the end of the block. So then we have the code that is going to be written inside the block that is going to have a local scope. So let me declare another variable, y is equal to 50. Let me say y is equal to 50 in that case. So the variable y in that case is only known in this block. It is only known in this if block. In other words, only accessible. Just say only known within this block. It is only known within this particular block because we've declared it inside that block, so it is only known within that particular block. So if we are trying to print x and y, I want you to see we can print x and y inside here. Let's say system.out.println. You want to print x and y, so let's just say x plus y. Now there is no error, as you can see. There's no error. Why? Because x is global, is public. Y is actually local, but we are trying to access y inside this scope, which is actually a nested scope. That is it is a scope that is nested within the public scope. So but the problem comes in if we are trying to access y from outside here. So for example, if I try to reassign y, say y is equal to 400, boom, error. Look here, you see an error. Y cannot be resolved to a variable. Why? I'm trying to reassign y, but y was declared inside, so it has a local scope, so it cannot be accessed outside here. It's giving us an error. So we can comment out this code. Again, let's come still outside here. Let's try to access x. Let's try to print x. System dot out dot print ln. Let's print x. So if we print x here, notice there is no error. Why? Because again, x is what? X has a public scope. So if we run this, run our code, and we check the output, we see 80 and 30. So let's come to our code here. Where is 80 coming from? Here, the 80 comes from this line. We are saying print print x plus y. Print x plus y. In other words, take x, add y to it. Okay, so we get 80. Then here we are printing x. X is what? X is declared as 30. So if we want to print y, we can only access y from inside here. We cannot access it outside here. So that is about variable scope. So it's important for us to know that we can declare variables at any point within a block, and those variables are going to be valid only after they are declared. So the variables are visible only to that particular block that we declare the variables in. So code that is actually declared in the main class is accessible to all the code in the program. That is why we can access x because it is declared in the main. So if you declare a variable at the start of a method, that variable is going to be visible to all of the code within the method. But that variable is, if you declare it at the end of the block, then it is effectively useless, because the code will not be able to access that. I'm going to demonstrate this much later. So variables are created when we enter the scope of the variables. Variables are created, and they are destroyed when we actually leave the scope. That is, for example, a variable will not hold its value once we have gone out of the scope. So the lifetime of that particular variable ends once we exit the scope. For example, if we come and exit here we come and exit this block here after running this. So you see now y has lost its life. Y has lost its life. So I want to stop there for today. In the next class, I'm going to talk about type conversion and casting. We also talk about type promotion. Oh.